Why can a qubit look like a superhero in a demo, and then fall apart like a nervous wreck in real hardware? In the energy filament theory, a qubit is a controllable phase formation in the energy sea, and its power and fragility come from the same thin phase bridges the environment can record. Textbooks love to hand you T1 and T2 like they're magic stats, then act surprised you still don't feel what's happening. In this view, there are two different kinds of damage: energy leakage and phase damage. Energy leakage is like a battery slowly draining. Phase damage is sneakier, the energy can stay almost the same, but the coordination that makes superposition useful gets smeared. People say a qubit is 0 and 1 at the same time, but the thing that does real work is the phase relationship between those possibilities. If that relationship stays sharp, interference can act like a filter. Paths that arrive in steps get amplified, and paths that arrive out of step cancel. That's not poetry, that's how a quantum algorithm turns many options into one answer is statistically favored. Now picture the glass bridge metaphor the right way. Imagine a transparent sky bridge between two buildings, and what's crossing it is not a person, but a marching band trying to keep one shared beat. The band can do impressive tricks only while the beat stays aligned. A glass bridge feels strong until someone starts tapping the rails, shaking the panels, or filming your footsteps in ultra-clear slow motion. Nothing needs to push you off. It only needs to capture enough detail about your timing that the band can't stay synchronized. That's what the environment does to a qubit. The wiring can do it, the readout resonator can do it. Defects in the substrate can do it. Warm surfaces can do it by tossing stray photons that carry away what phase clues. Tiny couplings become tiny microphones. And once those microphones could even partially distinguish more like 0 from more like 1. The secret is already out. The information doesn't have to travel far to be fatal. It just has to exist in outside degrees of freedom. Then the qubit you track is no longer one crisp coordinated rhythm. It becomes a mixed situation, and interference contrast fades first. That's why decoherence is not the same thing as heating. You may not lose energy, but you lose privacy. You can keep your wallet and still have your password copied. This is why quantum hardware looks so absurdly overbuilt. Deep cryogenics, layered filtering, heavy shielding, vibration isolation, careful packaging. It's not aesthetics. It's a privacy budget. You're trying to calm the local seas, lower the background jitters, and stop phasing fingerprints from leaking into the outside world. And it also explains why measurement feels violent in practice. Measurement isn't you looking. Measurement is coupling, then closure, then memory. To read a qubit, you deliberately open a channel to an amplifier that can tell the difference. And that act is basically broadcasting the beat. Nothing collapses because you stared at it. It collapses because you plugged it into a settlement machine that can keep a record. Once the recording is real, the system is pushed into the pointer state corridor that stays stable under that coupling. And you see a single classical outcome. A qubit is powerful because you can choreograph the phase. A qubit is fragile because choreography can't survive in a room that keeps taking screenshots. Tap follow, share it on New Physics, Clear Universe.